hello everyone, Laurent Michelet speaking. I hope you can hear me properly. So in the next 10 minutes, I'm gonna introduce quickly the electrical installation guide and the online version, the electrical installation wiki, before passing the ball to Jacques for a more general overview and updates on IEC 60364. So what is the electrical installation guide and the electrical installation wiki? And please feel free to add in the chat if you already know this guide or the wiki. I'm interested to know if you are already aware and if you already use it. So the electrical installation guide is a book, more or less a 600 pages book that has been created over 30 years ago by our experts. The aim of this book and of the content is really technical knowledge on how to design electrical installation, low voltage electrical installations in particular, according to the IEC standards, the IEC 60364 in particular. So it's been written by our experts and they update it regularly according to standards evolutions or to share their state-of-the-art knowledge, on new topics. And recent evolutions are also focusing on new topics, which are also inside the IEC 60364 more and more around energy efficiency, prosumer installations, EV charging, and etc. And the electrical installation wiki is more or less the same content online. And to tell a bit more, what I'm going to do is start a quick tour on the live wiki. Hope it's going to work properly. Let me share my screen and you should see. Okay, I suppose you can see my screen. So you can see here the homepage of the English international version of the electrical installation wiki. The look and feel has changed beginning of 2020, to become responsive, so that you can now search with your mobile phone in the electrical installation wiki. And let me show you very quickly what it looks like. And if you use it on your mobile phone, it will look more or less like this. So as you can see, it's still pretty easy to navigate through the electrical installation wiki. I don't really recommend to use a mobile phone because it's much easier on a computer, but if ever you have no choice, it's still possible. So as you can see, the content is the same with the different chapters and topics, architectures, protection against electric shocks, etc. New topics like energy efficiency or photovoltaic measurement. You can still download the guide in PDF. And you have links to other related documents. And the last point, you can also contribute. It is a wiki like Wikipedia, so you can always just make a comment to report a problem or a question or improve a topic directly if you want and if you know how to do that. Let me come back to standard computer desktop view. What I'm going to do now is make just a quick introduction on one of the latest big update we did in the content with this new electric vehicle charging chapter. Okay, to save time, I already loaded the other pages because my connection is not that well this morning. Okay, so you see here the electric vehicle charging chapter. In this new chapter, you will find information about the trends, because it's a very fast growing market. And there is a lot of initiatives worldwide to boost the evolution and create new vehicles. There are countries who are taking engagements to ban internal combustion engine cars. It's a fast growing market. The cost of EV cars is going down and should be below ICEs by 2023, according to Bloomberg. It's going fast in many places worldwide. And of course, EV charging infrastructures have to follow. You will also find some general information about electric cars, the different charging modes, how much time it takes to charge an electric car. You also have some information about how to design and the standards and the requirement of the standards for EV charging station for Mode 3 and Mode 4. There is also one dedicated page, which is the core part of the electrical installation guide, to share the rules, specific rules to integrate EV charging infrastructure inside electrical installations with the different requirements from part 7722, like, for example, the specific protection against electric shocks that are provided there, like the requirement to add 30 milliamp RCB. Also, another page on architectures where we provide some general guidelines on how to integrate these new loads into existing installations, and also example of architectures. Another page, on digital architectures, where you will see the potential and importance of using load management systems with static set points or with dynamic set points. And finally, some perspectives on the future with the potential of V2G compared to V1G, which can bring even more using those new EV cars and EV charging infrastructures. So let me stop sharing. This was it for a very quick introduction of the Electrical Instrument Wiki. So as a synthesis, the standard, the IEC 60364 standard, for example, is setting the rules and the goals to reach. And the Electrical Instrument Wiki and the guide are there to support and explain that in a more concrete way. It's updated regularly. The wiki is available at any time. There's a lot of information there, so feel free to get there anytime and to send back feedbacks there if you have any comments or questions or suggestions. So now I'm giving back the ball to Jacques for the presentation on the standard itself.
Thank you very much, Laurent, for this really interesting presentation on the wiki, which is very helpful for most of our customers to understand very well the implementation of 60364. We have a poll now, Nikita?
Yes, I've opened the poll for our audience. I request the audience to please check the chat, and the poll is live for you to answer it.
Okay, Nikita, for the poll.
Yes, we have a number of responses, so we can go to the next slide. I'll just quickly share the results.
Okay, so this is the result. It was C and D. Okay, so I will introduce to you the IEC 60364. So we are going to check what is the scope, the definition, some vision of the earthing system, the conformity of the product standard, and the separation of the circuit. So this is for the part one, which is quite important to know in 60364. If you have something to remind for today on the 60364, this is really the overview of the structure. As you know, that 60364, this is something like 37 different standards, which are located in what we call different parts. So what you have to remind is we have the following parts. So the first part is the part 1, where you find the scope, the compliance to the standards, the definition of the different earthing systems, so TN, TT, and IT, and also the separation of the circuit. Then we have what we call a part 4. The part 4, this is really protection, and we have different type of protection. The first one in the part 41, which is the protection against electric shock. The part 42, this is thermal effects, so fires and burns. 33, this is protection against overcurrent. And 44, this is protection against overvoltage and EMC. So in this part 4, this is where we require or not to put the different type of protection regarding what you want to protect in your installation. Then you have the part 5. This is how to erect and select the different equipment. And then we have different part 5 regarding all the structure. This is really the way you implement and select the different products in this part. Then we have a new part 8, which is all the functional aspects. So in this part 8, you have a first part, which is 8-1, which is energy efficiency. And then we have 8.2 and 8.3, which is about prosumer installation. And this part is really something which is really important to implement nowadays. Because, for example, when you spoke about EV charging station, you are a prosumer installation in most of the case. The numbering looks strange because it's part of the history. So, but just remind that we have part 1, 4, 5, and 8 for the selection and direction of the different installation. Then we have something which is very important, is the part 7. So the part 7, this is something which is very specific to IEC 60364. This is documents which are going to modify the part 1, 4, 5, 8, and 6. That means that if you have something in this document, you are going to use the main part plus the part 7. So that means that the part 7 is not a standalone part. And sometimes I have people saying, oh, for EV, for the 722, for EV charging station, you have only 10 pages, so it's quite easy. No, this is 10 pages plus the 1000 page for the other part that you have to use for EV charging. So this is really the way you are going to use the part 7. And then we have the part 6, which is the verification of the installation. And we have two parts on this part 6, the verification of the new installation and the periodic verification. So keep in mind this picture, and it will be very easy when you are in the different part of 60364 to understand in which part you are referring to. So the advantage of this structure is this is worldwide adoption by the international community. So more or less except North America, all the countries use 60364 for implementing their national installation rules. The good thing, this is a consensus. So this is a result of the vote of the member country of the IEC. And this is also something which is general. This is a catalog dedicated to general rules regarding safety. And there is no final solution. So this is also something which offers a lot of flexibility. This is a coherent system. When you use products which are IEC products, we reference this product and we have a consistency between this product and the installation. So this is a guide to elaborate the national standards. So in most of the country, you never use 60364, but your national standard, which is made from the IEC 60364. And it's also a good way to promote the international trade. So regarding the deployment from this, as I told you, most of the country today use for the transcription in their national standard, the IEC 60364. And you see, depending on the color, more or less the adoption. So it could be more or less 100% or 90%. And in some country, it's only few parts which is used in their national rules referencing 60364. So more or less, except North America, which is linked with the NEC, North America Electric Code, all the other countries use 60364. And this is also the difference that all these countries use IEC products. So it's very important to use IEC installation rules, where in North America, they use NEMA product. So there is some example of the local number for your installation rules. And you see in your country, this is what you are going to adopt. The benefits sometimes of the standards, some people say, oh, standards, this is just a document, but what are the benefits regarding this standard? And we have one example with the C1500 in France, which is fully based on IEC 60364. This is the implementation of the standards and the implementation of the RCD, for example, regarding the protection against electric shock. And you see these standards, so the equivalent of 60364, was mandatory in the 1970s. So this is the year of reference. And in France, there is almost 3 deaths per million of people a year regarding electric shock. We implement the different recommendations and then some requirements regarding the RCD. So it was recommended in the 80s and then mandatory in the 19s. And we see really the decrease in the number of deaths regarding the implementation of these standards. We still have a backlog of all installations, so this is why it's not close to zero. But more or less nowadays, using these standards deliver a very huge advantage in terms of safety and protection against electric shock. So this is one example. For sure, you have other examples regarding protection against thermal effects, protection against overcurrent or overvoltage. Small quiz just to remind you. So which of the following does IEC 60364 protect against? So A, earthquake damage, B, electric shock, C, thermal effect, D, flooding damage, E, overcurrent, and F, overvoltage. Please, you have a few seconds to answer. Okay, I think it's time for you to answer. So the answer was, as you know, protection against electric shock. This is the part 41. Protection against thermal effect, part 42. Protection against overcurrent by 43. And protection against overvoltage, part 44. So thank you for your participation to the poll. Regarding the new safety requirement in the IEC 60364, we are going to check what we are in the different parts, so 41, 42, 43, 44. We are also checking what we have in the part 6, verification of installation, in the part 7, part 6, sorry, for part 7 for special location, sorry, and in the part 8 regarding prosumer installation. So regarding part 41, this is the protection against electric shock, and we have 3 types regarding this protection. What we call basic protection, this is a protection again under normal condition. So you have to make sure that when you use normally your installation is safe. So this is what we call basic protection. We have, when we have under a single fault, this is what we call fault protection. And we have also some additional protection that should be provided for some circuit or some location when the risk regarding electric shock is higher, for example, when we have presence of water. So in the last revision of the part 41, which was introduced in 2017, we had some new requirements. So we had the additional protection for lighting circuit in dwellings. So in this case, you need to protect with RCD less than 30 milliamps. So this is mainly when you change the bulb of your luminaire, there is a risk that you fall down, and to protect against this risk, we now require to have RTD for this circuit. We also push the additional protection for socket outlet to circuit up to 32 amps instead of 20 amps. When it's used by unskilled people or ordinary person, it was 20 in the past. And you see that in mode 2 nowadays, you could reach 32 amps with the socket outlet. So it was really important to have this additional protection for this circuit up to 32 amps. And we have also additional protection required for AC mobile equipment for outdoor use up to 32 amps, also by RCD. So check this, and probably you have to introduce this in your national installation rules. Regarding thermal effects, once again, we add now new products to protect against thermal effects. This product is called AFDD, so arc fault detection devices, to protect the arc in the final circuit. So in the chapter 42 in 2014, we implement a recommendation for the use of these devices. So now you have two recommendations to use in some premise like sleeping accommodation, bedrooms, hotels, in location with risk of fire due to the nature of process or stored material, in the location with combustible constructional material, in fire propagating structure, and in location endangering of irreplaceable goods like museum or historical building. So this is really a first step to better protect some location where the fact that you could have a fire will damage life, human life, or goods. And it's really important to implement this kind of device in such a location. So of course, as you know, you have to select the product device according to this its standard. So in this case, for FDD, the standard is the IEC 62606. We are currently revising this also part 42, and we probably expect to have a new standard next year. And then in this new standard now, we push from recommendation to mandatory use of FDD in a similar location. Regarding overcurrent, so nothing new in the standards regarding this part 43, but mainly we revise the part 5, so in this case 53, where we define new rules for coordination of different devices. So mainly you will see that this part 53 was updated in 2019, and there we really improve the selection and direction of the different devices, and especially the coordination rules. Regarding part 44, overvoltage, we updated this chapter in 2015, and now the protection against overvoltage is mandatory for some application like safety services, museum, hotel banks, and risk assessments have to be done for some installation, many dwellings installation, and then depending on the risk of overvoltage on one side and the consequence which is are given, which is economical risk of the installation, you have to protect as a mandatory protection for some installation, or it's not really, it's just a recommendation for the other installation. It's really what you have to consider that we have more and more electronics in the installation, and therefore they are much more sensitive to overvoltage than resistive load like we have in the past, and more protection against overvoltage become mandatory in the installation. So it's also something which is really important to implement. And then you have also in the part 5 the way to implement this overvoltage protection, which is very important, because if you don't install correctly the overvoltage protection, then it's not effective at all. In the part 6, verification of installation, it was revised completely in 2016. And then now we have two different parts. We have the first part, which is initial verification, where we have inspection and test. Mainly, we verify that the effectiveness of the protection and how it will be erected correctly. So it's very important. But nowadays, we also introduce much more requirement for periodic verification. And it's really important also to think about periodic verification, because you see nowadays the usage of the installation vary a lot. You implement PV panel, you implement EV charging station, sometimes you implement new loads, and therefore you have really to make sure that the protection is for sure still present, but also still effective. And the calculation you do, especially when you use TN system for your protection, are still effective. So it's really important. And then also you have to take the protective devices like the RCDs, that they are still operative. Really, periodic verification in dwellings is something that you have to think about mainly every 5-10 years. It could be something which really contribute to the safety of the electrical installation. We have also implemented some updates in the chapter 7. So the safety rules for special location. Once again, be careful because the part 7 are not standalone standards, but really a standard that you have to use in conjunction with the other part of 60364. So 1, 4, 5, 8, and 6. And then we have some new chapter regarding bath and shower rooms 2 years ago. We start the revision of the part 702 regarding swimming pool and fountain. And then we revise the 704, construction and demolition site. We also revise the caravan park and camping park and similar, 708. 711 for exhibition, show, and stand. The medical location was updated this year, so this is 710. And then there is a lot of requirement regarding medical location. 712 was updated for photovoltaic 4 years ago. And there is a lot of new requirement compared to the former version. So it's very important that you update your part 712. And 722 was updated also 2 years ago regarding EV car. And it's also something that we introduced. It's also important to update. So you see there is a lot of modification and updates to be implemented in your national local installation. Then you have 8.2 regarding prosumer installation. So currently we addressed what we call prosumer. So prosumer, you produce and you consume your installation. And you see that more and more due to energy efficiency, building regulation, you have production in your building, and then it becomes prosumer installation. So this is really important to consider also this 8-2. Currently, the first edition was produced 3 years ago, and we expect to have edition 2 next year in 2022. So, if you have to remind the different chapters, and this is just a way to sometimes to link with the product and in your installation what you have. So you have to protect against electric shock thanks to RCD or circuit breaker or OCPD, fuse. You have to implement thermal protection thanks to 30 milliamps RCD or AFDD for finite circuits. Protection over current by OCPDs. Protection against overvoltage by SPDs, such protection devices there. You have to make the inspection. You have to consider special location, and you have also to consider the prosumer installation. So it was mainly what I would like to introduce to you for the new part, and where I would like to focus more in one part 8, which is nowadays very important. When you see the price of energy rising, it will be a question that all the customer will ask you, what I can do to save energy, and then implement 8-1 is very important. This is where you could make your installation more efficient. That means that you are going to deliver the same services to use less energy. So this is really implemented. This part 8-1 is really the way to use less energy for the same level of service. And the consequence of that is really that you are going to reduce the energy bill of your customer. So for doing that, we are going to first thing to determine the load demand. And when you make the protection for safety, usually you use the installed power in kVA. There, for energy efficiency, you have to consider the load demand. That means if you have a big load, but you never use it, you don't consider for energy efficiency. On the opposite way, if you have even a small load, you are going to use a lot, then you have to consider it for energy efficiency. So this is why determination of load demand is very important and has to be considered for energy efficiency. Then we are in this chapter do three main things. You are going to minimize the energy losses in the electrical installation. So mainly reduce the voltage drop within the installation, and you have a lot of methods to do it. You are going also to use the energy at the right time when needed and at a lower cost. So this is something which is specific to electricity. The price of electricity may vary, and the payback on the implementation of your energy efficiency measure will also has to be considered regarding the price of the energy, which are going to depend on your utility and your provider of energy. So it's also something which is specific, and we are going to, for design this, to consider what we call meshes, which is circuits with regard to energy efficiency, and some optimization of the use of electricity by controlling the electrical installation. So this is what we call energy efficiency management system. And then the last chapter, which you have to consider, is really very important, is to maintain the performance. Because the way you are going to use your installation is going to be modified by the usage and by the time. So we have really to maintain this performance, and we have also to offer a life cycle methodology and an assessment process in order to make sure that you keep your installation efficient regarding the usage of electricity. In this chapter, we are going to use the different parts. So to do that, on the method, we are going to define what we call zone, mesh, and usage. Based on that, you are make probably new circuits in order to better control your usage of electricity. You are going also to make and implement an energy management system. And then regarding the measurement system, we are going to refer to 61557-12 and all the energy management system. Depending the type of installation that you have, you are going to use a BMS, HBS, or BAC system, depending on that. We have, as I told you, a life cycle method in order to maintain the building performance. This is based on what we call the passive energy efficiency measure, which is made on the basis, and the active electrical energy efficiency measure, which is made on automation and control, the monitoring of the installation to improve it, and also the control with verification and maintenance of your installation in order to make sure that you maintain the level of efficiency of your installation. So this is also something which is very important to implement in your installation. And then the last thing that we have regarding this is an assessment method that we introduced in the edition 2 of the standards. And then we have different levels of efficiency of your installation. And make sure that if you have the level 3, which is reached at the beginning, initial installation, you keep this level, at least this level, when you use your installation after 2 years, 5 years, and so on. So this method gives you the way to make sure that you have the level of efficiency that you want to have. The method is mainly based on some table and some points, and depending the type of your installation, if you are in a residential installation, industrial, commercial of infrastructure, you have different number of points, and based on these points, you have a level of efficiency on your installation. To sum up, 60364 is really the standard when you want to implement a safe but also efficient electrical installation. For sure, 60364 needs to be locally adapted to national constraints and develop and enrich. So this is why you never use 60364, but a local implementation of the standard. We also, and you see that we address the new usage of electricity. And today you see that the way to design and to implement the installation is moving fast. You have, frankly speaking, a lot of new usage, a lot of new way to use electricity, not only inside the building, but also outside the building. And it's very important to consider new risks regarding this usage of electricity. And this is today the way that 60364 address this new usage. It's also a reference for countries which not already implement a local standard. They could use 60364 directly. Yes, once again, this is just a reminder that in the Schneider Electric portal, you will find a lot of information regarding 60364, and you have the usage of Wiki. Once again, this is based on 60364, so you could have some slight difference when you implement in your country. And don't forget that this is a guide, but sometimes locally you could have some slight difference regarding this reference guide. So now it's time for question and answer. I give you back the floor, Nikita.
Sure. Thank you so much. So, I'm just checking if there are any other questions. I see that Lauren had already answered one of the questions on chat. I request the attendees, please let us know in case you have any questions. You can either post it on chat or you can quickly unmute yourself and ask the question as well. So we'll leave a minute or two for you to ask questions. Meanwhile, I'll just open the poll, the last poll that we have. We would really appreciate it if you could give us your feedback in terms of how the call was in terms of delivery and topic. So I'm just opening the poll for you right now, and I request you to please fill up the poll according to your preference. We have a question from one of the webinar attendees. Is IEC 60364 available as a single volume, or are each chapter and section separate documents only?
No, today this is separate books at IEC level. But once again, sometime in the country, it could be used as a single document. So it's really depending on the country. But for 60364, it's some different parts. We were thinking to use it as a single document, but it was really not possible at IEC level. And it is done only in some country at local level.
Thank you so much. Do we have any other questions? So I think we're good with questions for now. I will also be posting a link to Exchange where you can check the page on Exchange where we will be uploading the webinar recording, and you can access the recording in terms of today's session in about a week or two's time. And you can also post your questions or any other queries that you have later on Exchange, and our speakers will try and answer your questions to the best. Uh, I think before we close, we have one last question. In terms of specifying the efficiency for industrial product, is it mandatory to rate it by manufacturer?
Sorry, I didn't catch you.
In terms of specifying the efficiency for industrial product, is it mandatory to rate it by manufacturer?
No, nowadays regarding efficiency, there is some regulation in some countries, but in most of the countries there is no regulation, and it's much more something which is a voluntary things which is done by the customer. Probably in the future there is some regulation pushing for this kind of efficiency, but nowadays this is not mandatory except in some country where we have already some regulation which are implemented.
Thank you so much. I think we can take one last question. How many separate documents does IEC 60364 comprise? Is there a comprehensive list of documents?
Yes, if you go directly to the IEC.ch website, which is available for everyone, and then you could go to you make a search, and then if you type IEC 60364, you will have a lot. You will have the comprehensive list of documents. You could go also on IEC.ch and go to TC64, and then you have a folder which is publication, and then you have the list of the publication. You have also all the information regarding the project we are doing right now, and most of the information are available to everyone. For the technical content, it's only available for expert registered at expert of TC64. And then you have to check with your national committee to be registered as an expert. You could also participate if you want to bring your expertise to TC64 as an expert. In this case, go to your national committee to ask to become an expert, and then you could participate. But if you're not an expert from TC64, go to the IEC.ch website, check TC64 or IEC 60364, and you will find all the relevant information you want. And even you could buy the standard directly on this website.
Thank you so much. I've received another question. Maybe we can look at that as well. How does IEC 60364 efficiency recommendations compare with lead requirements?
Compare to, sorry?
Compare with the lead requirements, LEED, lead requirements.
This is something which is not exactly the same. We focus only on electrical installation, where lead looks to all the aspects of the building. It could be also transportation, how you have a public transportation close to your building and so on. So this is some concepts which are much more, I say, complementary. But if you implement IEC 60364, you will be able to reach some requirements required by the leads regarding the efficiency of your building. But this is something which is totally different. One hand, this is something which gives you a kind of certification regarding the implementation of different measures regarding the building, where 60364 we focus on the electrical installation, and then also once again the benefit of that you are going by implementing 60364 your electricity bill for sure. Where the lead, if you are close to a public transportation, there is no impact on your electricity bill for this kind of measure.
Thank you so much. I think we have one more question. We can maybe take it as the last question. Why should there be arc fault in places like bedroom and museum? Or is it being confused with overheating, leading to fire in the absence of proper protection?
I'm sorry, I was not able to catch you. The line was not good. Could you repeat the question?
Yeah, I've posted it on chat as why should there be arc fault in places like bedroom and museum? Or is it being confused with overheating, leading to fire in the absence of proper protection?
No, the fact is really what we consider is regarding the protection against thermal effect is really the fact that what's happened if there is a start of a fire. And then if you are in a museum or such a things, you could replace the goods which are in the museum. And the same thing for the bedrooms. The bedroom, you are supposed to sleep, and therefore you are not able to, in some case, to wake up and escape from the fire. So this is why we nowadays push for the time being recommendation, and we are going to push for a mandatory use of arc fault detector device in order to avoid that a fire could start on the electrical installation.
Great. Thank you so much, Jack. Thank you so much, Lauren. I think we're good with the questions now. So I will quickly take the opportunity to close this webinar. As discussed, we will be posting a link to Exchange from where you can access the webinar recording in about a day, in about a week or two's time. You can also find the comments related to the webinar, or in case you want to ask any questions to our webinar speakers later, you can post your questions there, and our speakers will answer the questions accordingly. Again, thank you so much, speakers and attendees, for today's session, and I hope it was a great session for all our webinar attendees. I hope all of you have a great day ahead. Thank you so much.
Thank you. Bye-bye.
Thank you, everyone. Bye-bye.